Assalamualaikum warahmatullahi wabarakatuh. My name is Ain Binti Mohd Khusairy Faisal and I'm going to present my final year project. The title is The Approximation of Quadratic and Cubic Bezier Curve. First of all, introducing abstract for the my study. The approximation of a curve in a topic of Bezier curve is one of the methods that are commonly discussed in the area of computer-aided geometric design (CAGD). The study focuses on the two methods, which are quadratic Bezier curve and cubic Bezier curve. This study aims to approximate the quadratic and cubic Bezier curve and make a comparison between the quadratic Bezier curve and cubic Bezier curve with their properties. The data used in this study is the location of control points for the curve. In this paper, the expanding equations from the basis function of that two methods are used to approximate the curve in MATLAB software. The results show that the cubic Bezier curve has a better results compared to the quadratic Bezier curve by comparing their properties. It can be said that the cubic Bezier curve are more popular compared to the quadratic Bezier curve due to its flexibility. Feng 2014. In conclusion, future studies on the current topic are therefore recommended. Also, future researchers can expand the degree of the Bezier curve, which is more useful in computer-aided design, CAD, CAGD, and engineering. As an introduction to Chapter 1, I begin with the background of the study. Bezier curves were studied in 1962 by Pierre Bezier, a French engineer who started to use them in designing bodies of an automobile. Through the property of convexity of control polygon, the curve has characteristic intuitiveness in conveying the desired shape. Fitter et al. 2014. However, the first study of this curve was developed in 1959 by a mathematician named Paul di Castellio, using the Castellio algorithm, a numerically stable method to evaluate Bezier curve. Kilichoglu and Sayed 2020. Hence, the theory is called Bezier, although Castellio was the first person who created it, since Castellio never published his result. Negus 2019. A Bezier curve is widely used in computer graphics, animation, computer-aided design (CAD), and many other related fields. Kilichoglu and Sayed 2020. There are several types of Bezier curve to approximate a curve, which are linear Bezier curve, quadratic Bezier curve, cubic Bezier curve, quartic Bezier curve, and quintic Bezier curve. In this paper, quadratic Bezier and cubic Bezier curve are the curves that are present to perform the study. What is the problem in my studies? Ideally, the approximation of a curve has done by comparing the two curves, quadratic Bezier and cubic Bezier in this study. These curves use the same method with a different polynomial. However, the basis function and equation for every curve are different between them. Therefore, the control points are needed to approximate a curve. In this study, two types of curve, quadratic Bezier curve and cubic Bezier curve, are approximate and make the comparison from the properties of quadratic and cubic Bezier. Therefore, the study is conducted to approximate a curve by using the quadratic and cubic Bezier curve as stated in the study's objective. Next, we move to the objective of the study. Firstly, to approximate the quadratic and cubic Bezier curve. The second one is to compare the quadratic Bezier curve and cubic Bezier curve with their properties. Anyway, what is the scope of the study? The study of the approximation of a curve by using quadratic and cubic Bezier focus on the quadratic and cubic Bezier methods. This study aims to approximate a curve by using quadratic and cubic Bezier, which is particularly useful in CAGD. After that, the study is conducted to compare the quadratic Bezier curve and cubic Bezier curve with their properties. The equation and control points in the Bezier curve are used in this paper. The functions used to approximate a curve are quadratic and cubic Bezier curve. The last point in the chapter 1 is the significance of the study. The first one is the approximate of a curve is applied to conduct a study on the approximation of a curve by using quadratic and cubic Bezier. Secondly, the study will bring benefits to other researchers that desire to carry out similar research on this topic. Furthermore, CAGD gives advantage to the designers in related fields such as engineering, science and technology, and geometric fields in their future design studies. Finally, the study contributes to the body of existing literature and knowledge in this field of research and provide information to further research. Chapter 2, we look at the previous study on the quadratic Bezier curve. This literature review represents Choi, Curry, and Elkame 2011 analyzed the problem of minimizing the curvature of a quadratic Bezier curve within a boundary constraint determined by tetragonal concave polygon. Minimizing the maximum curvature may be necessary for a curve design such as highway design and motion planning of autonomous vehicles. At last, the method to smooth a piecewise linear path generated from a path search technique is demonstrated by numerical results. Next, the arc length and bending energy of the quadratic Bezier curve were studied by Ain, Hoffman, and Rosen 2013. These formula used are in terms of coordinates of the control points. The basic algorithm amounts to sampling candidate contact points along a specified tangent or tangency circle and verifying the arc length or bending energy. Last but not least, the previous study on the cubic Bezier curve. The first one is the work presented by Rusdi and Yahya 2015 proposed 4 images: fork, add, plan, and love to obtain the outline of the bitmap image and to minimize the distance between the boundary of the original image and parametric curve. They conclude that LSM is an efficient algorithm for approximating the image boundary since the result shows for bitmap image produce the least SSE. In conclusion, the cubic Bezier curve is used to find the best optimal curve for the data extracted by bitmap image. Rusdi and Yahya 2015. Other than that, in 2017, Asghar et al. Presented a multidisciplinary strategy to automatically improve image filter using low and high pass pattern in the frequency domain by intensity transformation in the spatial domain using a cubic Bezier curve. A Bezier curve is a smooth curve that is often used to represent data. The cubic Bezier curve was described and used to simulate the contrast enhancement problem in various situations based on scene or image type. The control point of the cubic Bezier functions can be adjusted to get the desired curve shape for contrast enhancement. Next is Chapter 3. The method of data collection in this study is illustrated as shown in Figure 3.1 on the left side. This study focused on the two curves to approximate the curve. The method was applied to approximate a curve by using the quadratic and cubic Bezier curve. The method of data collection began with a literature review of journal articles or other reading material were reviewed to provide supporting details and reference in this study. Secondly, the data is collected by locating the control points of the curve. Next, the equations used were expanded from the basis function of quadratic Bezier curve and cubic Bezier curve. After that, MATLAB was used to approximate the curve of quadratic and cubic Bezier curve. When the curves were obtained, both curves were compared to see the difference in terms of the number of control points. Moreover, two curves, quadratic and cubic Bezier curve, were compared in terms of their properties. The data used for the control points of the curve are presented in Table 3.1 on the right side. In the points of 3.2, we can see that the method of data analysis. The basis function for the quadratic Bezier curve is taken from Bezier et al. 2012 and Kilichoglu and Sanyut 2019 given in definition 3.1. Meanwhile, to approximate a curve by using the cubic Bezier method, the basis function for the cubic Bezier curve is taken from Kilichoglu and Sanyut 2020 as given in definition 3.2. Definition 3.1. A quadratic Bezier curve is defined as follows with three control points: Pi equal to P0, P1 and P2. Bt equal to summation 2 I equal to 0 Pi 2i times 1 minus t power of 2 minus I times t power of I and t in range of 0 to 1. Expanding equation 3.1 use Bt equal to 1 minus t power of 2 times P0 plus 2t times 1 minus t P1 plus t power of 2 P2. The following figure contains graph of basis functions for the quadratic Bezier curve. While in definition 3.2, a cubic Bezier curve is defined as follows with 4 control points: Pi equal to P0, P1, P2 and P3. Bt equal to summation 3 I equal to 0 3i times t power of I times 1 minus t power of 3 minus I times t times pi. Expanding equation 3.3 yields b t equal to 1 minus t power of 3 times p naught plus 3t times 1 minus t power of 2 times p1 plus 3t power of 2 1 minus t times p2 plus t power of 3 times p3. On the right side is the figure contains graph of basis function for the cubic Bezier curve. Now on chapter 4, I will present the results and discussions. As continued from the previous chapter, this section 4.1 provides the results from the MATLAB software. The MATLAB was used to run the command and obtain the outputs for the approximation of quadratic and cubic Bezier curve. As shown in figure 4.1, there are 3 control points needed for the quadratic Bezier curve, which are P0, P1 and P2. These 3 control points will form in the control polygon. The expanding of basis function for quadratic Bezier curve from equation 3.2 will combine with the control points P0 equal to coordinate 10, 10, P1 coordinate 30, 55 and P2 coordinate 60, 50 to generate the curve. From the figure, it can be seen that the t increased from 0 to 1. The curve turns away from P0 in the direction of P1, then bends to arrive at P2 from the direction of P1. In figure 4.2, the cubic Bezier curve is defined as follows, with 4 control points, P0, P1, P2 and P3. These 4 control points will form in the control polygon. To construct cubic Bezier curve, the expanding of basis function for cubic Bezier curve from equation 3.4 will combine with the control points P0 equal to coordinate 10, 10, P1 equal to coordinate 30, 55, P2 equal to 60, 50 and P3 coordinate 80, 28. The curve start from P0, move away to P1 and P2 before end with P3. From the result in figure 4.1 and figure 4.2, it can be concluded that the difference from the two methods, quadratic and cubic Bezier, are the number of control points. As revealed by the result from MATLAB, the graph for quadratic and cubic Bezier curve have 3 and 4 control points respectively. Other than that, the shape of curve for quadratic and cubic Bezier curve was contained in the control polygon. The results for the approximation of quadratic and cubic Bezier curve were obtained in this section. It shows that the first objective in this study was achieved. Thus, the section of 4.2 shows the comparison between both methods by their properties. Firstly, the property for the quadratic Bezier curve were taken from Zhang and Feng 2006. The properties of the cubic Bezier curve were taken from Zhang and Feng 2006. Also, the properties of the cubic Bezier curve were taken from Sarfraz and Masoud 2007 and Rusli and Yahya 2015. It can be seen from the comparison above that the properties of the quadratic Bezier curve are more similar to the cubic Bezier curve. The first comparison shows that both methods have curves passes through the control points at their own endpoints. Secondly, quadratic Bezier is a continuous curve. It has continuous derivative in all orders, same like cubic Bezier. But cubic Bezier has infinitely differentiable, also continuous for second derivative. These properties for both methods were automated because they were a polynomial curve. Thirdly, the quadratic Bezier functions are non-negative and sum to 1, similarly to cubic Bezier, are all positive. Next, both methods have the convex rule of their control points containing the quadratic and cubic Bezier curve. Thus, the quadratic Bezier curve is a straight line if the points P0, P1 and P2 are collinear, while only if the cubic Bezier curve is linear, both P1 and P2 are on the curve. Although the quadratic and cubic Bezier curve have other properties, but this paper has stated a few. This paper refers to Feng 2014 to compare the graph between both methods by its property. Feng 2014 stated that 2 end slope of the quadratic Bezier curve will never be parallel. However, the cubic Bezier curve can be used to accomplish this. Furthermore, the cubic Bezier curve are allowed to control the 2 end slopes separately, which the quadratic Bezier curve do not. Thus, the quadratic Bezier curve do not have inflection points, while the cubic Bezier curve may have inflection points if the control points are not carefully chosen. To sum up, the cubic Bezier curve are more popular compared to the quadratic Bezier curve due to its flexibility. Fan 2014. It shows that the cubic Bezier curve was better than the quadratic Bezier curve by comparing their properties. Hence, this achieved the last objective in this study. Now we have reached to the last chapter, which is the conclusions made and the recommendation offered in this study. Conclusion. The approximation of quadratic and cubic Bezier curve has been presented in this paper. This study started from the background of the study of a Bezier curve. Under a topic of Bezier curve, only two methods are proposed in this study, which is quadratic Bezier curve and cubic Bezier curve. For this study, it is important to have the control points for the curve. Also, the expanding equations are needed to approximate the curve of quadratic and cubic Bezier. As a result of the MATLAB, there are differences between two methods, which is the number of control points. The quadratic Bezier curve has 3 control points and the cubic Bezier curve has 4 control points. Both of them had the shape of curve contained in the control polygon. To achieve the second objective, this study compared the quadratic Bezier curve and cubic Bezier curve with their properties. From the results, the cubic Bezier curve has a better result compared to the quadratic Bezier curve. It can be said that the cubic Bezier curve are more popular compared to the quadratic Bezier curve due to its flexibility. Fan 2014. Last but not least, the recommendations. As all know, a Bezier curve is widely used in many related fields. There are many types of Bezier curve that can be found. The same goes to this proposed study under the topic of the Bezier curve. This paper has proposed the approximation of quadratic and cubic Bezier curve. Future studies on the current topic are therefore recommended. It may benefit to future researchers who are interested in this proposed study because they can use in the future. For example, it can be used for other applications other than focusing on its property. Other than that, future researchers also can expand the degree of the Bezier curve, which is more useful in CAD, CAGD, and engineering. Therefore, they can compare the results from their future studies with this proposed study. That's all from me. Thank you.